In this video, we'll be taking a look at how a flash sale took down our MySQL database. I develop and maintain an e-commerce solution for snack bars and restaurants. It's powered by Laravel on the backend, and at the time of the incident, we had a single server with Nginx, our Laravel application, and a MySQL database server. So this single server was responsible for everything. In the summer of 2020, we sold a license to a camping site that had over 5,000 guests. The camping site featured a bakery and a snack bar on site, and they intended to use our e-commerce solution to power it. Little did we know, the camping site featured a swimming pool that was limited to 200 guests due to COVID restrictions, and our system was about to be used in a way we hadn't anticipated. Camping guests were meant to purchase a free entry ticket that they could show at the entry gate of the swimming pool. And management of the camping site thought it would be a great idea to use our e-commerce system for a daily ticket sale at 8 AM. It was a particularly hot summer day, and as you can imagine, the limited entry tickets to the swimming pool were very desirable to the camping site guests. When the clock struck 8 AM, almost 5,000 guests scrambled to get online, some even with multiple devices, and tried to get a hold of an entry ticket for the swimming pool. And our system faced a sudden avalanche of requests. It wasn't long before our MySQL database collapsed, leaving thousands of guests disappointed. Being a multi-tenant system, the downtime was not limited to the camping site, but all our other merchants also faced downtime due to this sudden spike in traffic. This type of spike is called a flash sale. And while our system was over-provisioned for the average traffic it received, a spike of this magnitude exposed a flaw in our architecture. Our multi-tenant Laravel-based e-commerce solution had been up and running for around 10 years at that point. Before 2020, we had around 40 customers and handled an average of 80 orders daily. We handled this on a shared cPanel server, and we didn't think twice about caching. The need nor the budget simply wasn't there. By the summer of 2020, the amount of customers exploded to 400, and we were handling around 1,200 orders daily on average. By that time, we had already migrated off of the shared cPanel server into our own VPS managed by Laravel Forge. At the time, every page view ran around 40 MySQL queries to get the products, the availability, the business information, etc. Multiply this times 5,000 and you get 200,000 MySQL queries that ran within a minute, a thing our database server simply wasn't set up for. Taking a critical look at the information that was needed to render the page, we came to the conclusion that almost all this data could be cached indefinitely, with a few actions triggering the purge of said cache. The cache should be purged whenever a new order is placed or whenever the products or their availability changes. Now this was our caching end goal, but implementing a caching strategy of this magnitude takes time and resources, a luxury we simply didn't have at the time. To quickly mitigate our problem, we cached the entire data needed to render the page for 5 seconds in Redis using the Laravel cache remember method. This simple trick would trigger a database hit only 12 times a minute, meaning we reduced our queries from 200,000 a minute to a mere 480 a minute, no matter the amount of visitors. Looking at this graph, we can safely say that this mitigation was a step in the right direction. While not an ideal solution, this 5-second caching mechanism bought us the time to implement our endgame caching strategy. Even the slightest amount of downtime causes a massive impact for all our merchants, so we took this issue seriously. We took a step back and analyzed what had happened and how we could prevent this from happening in the future. So here are a few takeaways. Lesson number 1, stick to your niche. This entire situation hadn't happened if we simply did not allow tickets to be sold on our system. We're a food ordering platform where scarcity is almost never an issue. Food platforms and ticket platforms share virtually no similarities, and our system was simply not set up to handle ticket sales. On the bright side, this entire situation gave us hands-on experience into optimizing our system to handle flash sales. Lesson number 2 is to start thinking about a caching strategy much sooner. I'm not a fan of prematurely optimizing your applications, especially when you want to ship features fast. And even though this situation was a bit special on our platform, we suddenly had to scramble to implement a caching strategy to handle a massive influx of users, which was simply not ideal. In the future, I'll start thinking about caching strategies sooner and implement them before I need them. And lesson number 3 is to understand the weakness of a single database multi-tenant application. Multi-tenant applications come in many flavors and forms, and we opted for the single database architecture, which made it easy for us to manage our database and to ship out features fast. The biggest drawback here is the single point of failure. When our database fails, it fails for all of our merchants. Nowadays, we've started implementing mitigations against this by implementing a Shopify-like pod-based architecture. And if you want to learn more about this architecture, I will link it down below in the description. And that concludes the video. If you find this content helpful or insightful, give it a thumbs up and consider subscribing. And I will see you in the next video.